The year is 2033 and humanity has set its sights on a new frontier, Mars. Years of research and exploration have paved the way for a new chapter in human history, establishing the human colony on the Red Planet. This is a journey that will test our courage, our endurance, and our resolve. But it is a journey that will bring us closer to the answers we seek about our place in the universe. And so we embark on this journey to boldly go where no one has gone before, to Mars and beyond.
Regardless of whether or not life exists on Mars, human beings are determined to colonize in the coming years. Billionaire Elon Musk and several other wealthy business persons have repeatedly discussed their passion for starting a colony on the Red Planet. However, whether life can sustain itself on Mars is a question that remains largely unanswered. NASA and European and Chinese space agencies have set out several probes to determine the feasibility of life on the Red Planet. In addition to being observed by large telescopes, space agencies also analyze the Red Planet via Mars Reconnaissance Orbiter and Mars Rover. While the discoveries made by all space missions are important, the one discovered by rovers is more significant. It is mainly because these rovers are roaming around on the surface of Mars, contrary to other space missions. Thus, the findings obtained by these missions fall in a higher tier regarding the credibility of the evidence. In this video, let's talk about the Mars rovers and the discoveries they have made so far. Let's get to it. As of now, 3 active rovers are running on the surface of Mars. 2 of them are launched by NASA, which include Curiosity and Perseverance. Curiosity was launched in 2011, whereas Perseverance touched the surface recently in February 2021. In addition to NASA's rover, a Chinese rover named Zhurong was also analyzing Mars and was launched in 2021. It is important to mention that before these well-known rovers, several other vehicles also landed on Mars and transmitted important information back to Earth. These include Opportunity, Spirit, Sojourner, and Mars 3. All of these have now retired and are resting somewhere on the rocky terrain of Mars. Several other missions have been proposed, and some are under development. Each of these rovers has provided valuable information about the Red Planet, which has made us a step closer to answering whether it can sustain life. Let's take a look at some of the important discoveries made by them. One of the important missions of the Curiosity was to find whether life ever existed on the red planets, and as per the information gathered by the rover, it seems very plausible. It is important to mention that Curiosity was not designed to find evidence of life such as fossils, but rather to look for ingredients needed to sustain life. Within the first year of its landing, Curiosity found this site named Yellowknife, which was once home to an ancient lake. The initial analysis of the mineral left behind in the ancient lake determined that the lake's water was neither too acidic nor too salty, which means it was drinkable. Furthermore, the rover also found evidence of carbon, nitrogen, sulfur, phosphorus, and other elements that are needed to sustain life on a planet. The discovery that stands out was that Curiosity discovered the potential source of energy for microbial life. As per Vasavada, this spot could certainly support life, if it ever existed on Mars. In another region known as Gale Crater, Curiosity discovered an interrupted record of ancient lakes that likely lasted for millions of years. Interestingly, Curiosity landed next to a 3-mile-high mountain of sedimentary rock, which had a number of similarities with the Grand Canyon on Earth. Like the Grand Canyon, the younger rocks were on the top and the older ones at the bottom. By analyzing different layers of rocks, scientists can identify conditions in the environment in different time periods. As Curiosity started climbing this mountain, it encountered the remains of several lakes. Although the lakes are now long gone, the remnants of millimeter-thick layers of mud provided sufficient evidence to accept their existence. Scientists can also determine the ages of these lakes by analyzing the layers of mud that have settled out over time. Organic matter is what makes life. It is the core material of all life known to us to date. Curiosity also found that ancient Mars had enough carbon in the rocks and soils to serve as raw material for life. According to NASA, the lakebed of the Gale Crater had an abundance of a diverse range of organic molecules. Most of these carbon molecules are quite simple, but it is also possible that these might be broken fragments of large and complex organic molecules which have degraded over time. Considering the environmental conditions of Mars, it is a surprise that even those molecules survived such a long time. Perseverance rover, which was launched recently, also detected organic matter on the surface of Mars while collecting samples from the site of the ancient river delta. According to NASA, The rocks that we have been investigating on the Delta have the highest concentration of organic matter that we have yet found on the mission. The samples will be retrieved from Mars with a mission named Mars Sample Return, a mission that is planned for the 2030s. The atmosphere of methane has an unusually large concentration of methane, which was observed with a tunable laser spectrometer within this SAM instrument. The concentrations of methane varied seasonally, and about 10 times increase was observed during the 2-month period. It has made scientists curious about the origin of methane, and some believe it is quite exciting as it could be a sign of living organisms, as methane is produced by them. However, some also believe that methane could originate from the red planet's reaction between rock and water. Another theory is that UV light's degradation of interplanetary particles produces methane gas. It is believed that Mars has lost much of its atmosphere to space, but whatever remains of it is quite active. Curiosity analyzed the atmosphere by a process that concentrated selected gases. It provided precise measurements of the argon isotopes in the Martian atmosphere. The analysis revealed that Mars has argon-36, a lighter and more stable isotope, 4 times less in concentration than the heavier argon-38. It means that Mars favored the loss of light isotopes and retained heavier ones, which has made its climate thicker. Furthermore, Curiosity measures several other variables of the Martian atmosphere with an instrument called an environmental monitoring station provided by Spain. It has been monitored that the air temperature has climbed steadily, a phenomenon which is not influenced by the rover's location. In contrast, the humidity on the red planet varies from time to time and is different in different locations. As the rover landed on Mars, it experienced radiation levels that exceeded NASA's career limit for astronauts. It means without adequate protection, astronauts cannot land on the surface of Mars. The Radiation Assessment Detector instrument on one of the rovers detected 2 types of radiation that pose risks to astronauts on the red planet. One is galactic cosmic rays, which are produced by explosions of supernovas and other high-energy events happening outside the solar system. The second type of radiation originates from the solar flares and coronal mass ejection from the Sun and is known as the energetic solar particles. Years ago, a Mars orbiter spotted a rock formation filled with a mineral known as olivine. Olivine is a mixed crystal containing compounds based on magnesium and iron, the major mineral in the Earth's mantle. It measured about 27,000 square miles, approximately the size of South Carolina. The formation extended from the inside edge of the Gale Crater into the surrounding regions. Before the landing of Perseverance, several theories were proposed to explain the existence of such a formation. However, the latest Mars rover has analyzed the rocks to put all the theories to rest and instead has provided a more accurate explanation. According to recent studies, the olivine did not erupt on the surface but was rather a result of a slow-cooling environment. The study also determined the exact size of the olivine grains, which ranges from 1 to 3 millimeters. It essentially tells us that the mantle of Mars might not have the same composition as the Earth. That is all for this video. We hope it has been fun and informative. Stay connected with the channel to learn more from Mars rovers and other space-related discoveries made by the different missions in space. Thank you for tuning in. We will see you at the next one.